2D line interpretation management is part of the core application of PaleoScan 2018. It allows interpreting 2D seismic data to obtain an interpolated 3D relative time geomodel illustrating the geological organization of a basin. The interpretation of 2D seismic lines follows the same workflow as 3D seismic interpretation. It includes 2D line set creation, model grid creation and interpretation, 2D geomodel creation, 2D horizon stack creation and interpolation, 3D geomodel creation using the 3D horizon stack as constraint. Click on the File menu and select the New option to create a new project. From the main toolbar, click on the Import button and select the 2D line segue option. On the displayed interface, click on the folder icon, browse your 2D segue, and select the inputted files. For each line, choose to truncate the line depending on the trace number or the zip value. It is possible to modify the unit of the inputted 2D seismic lines. Other options such as the CRS, SRD or decimating options are available. Click OK to import the files. The imported files will be stored on the 2D line folder of the 2D line tab of the project browser. A seismic line can be opened in 2D by double-clicking on the name of the line. In order to create a 2D line set, select all the 2D line that will compose the set, right-click on the selected lines, and select the Create New 2D Line Set option. In the displayed interface, the upper right panel will show you the current seismic line. On the lower right panel, the Horizon Viewer allows to modify the location and visualize several lines. We strongly recommend to activate the values normalization so as to have consistent colors throughout the set. Click Save to save the 2D line set. Give a name to the set and click OK. The created set can be opened on the 2D viewer by double-clicking on it. A 2D line set viewer is composed of 4 sub-viewers. The upper left and the upper right sub-viewers represent the 2D seismic lines. The sub-viewer at the lower right represents the intersection of the two 2D lines. The sub-viewer to the lower left represents the map view of the 2D line set. It is possible to cross-navigate to modify the display of the 2D lines in the upper sub-viewers. Note that each 2D line is oriented with a letter system that is displayed at the top of the viewers. The letters are displayed on the Horizon Viewer. Each sub-viewer can be displayed as a full window size. A 2D line set can be opened in 3D by right-clicking on its name and selecting the Open in 3D option from the context menu. The main toolbar allows several options, such as resizing the height and width of the 2D line set. It is possible to display a real-time attribute on the 2D line set by selecting one 2D line and, from the Property panel Display tab, modify the attribute. The color bar of each attribute can be modified from the color bar panel. Although they will not constrain the future geomodel, it is possible to pick faults on the 2D line set. To do so, open a 2D line set and, from the Fault Module toolbar, click on the Fault Picking button. Click a first time on a 2D seismic line sub-viewer and a second time to activate the fault picking. click on the Validate button to validate the fault. From the 3D viewer, it is possible to merge some fault sticks. To do so, select two fault sticks and click on the Merge button. Various interpolation methods or fault properties are available from the Properties panel. Do not forget to save the faults by clicking on the Save Fault Set button. In the next stage, a model grid has to be created and interpreted so as to constrain the future geomodel. To create a new model grid, go into the Model Grid module and click on the New Model Grid button and select the New 2D Model Grid option. In the displayed interface, click on the set name so as to display the background. The patch size, the polarity, and the smooth level are three parameters that have to be set prior to create the model grid. Click on the Test Parameters button so as to visualize the preview of the model grid using these parameters. From the Properties panel Display tab, activate the preview and activate the grid display. Once satisfied by the parameters, click on the Save button to create the model grid. Give a name to the grid, mentioning the inputted parameters. A created model grid is automatically displayed on a 2D viewer. A model grid can also be opened in 2D by double-clicking on the model grid name. As for the regular 2D line set 2D viewers, the model grid viewer of the 2D line set is made of 4 sub-viewers. From the Model Grid module toolbar, click on the Tracking button to start your interpretation. At least two horizons must be interpreted, one at the top and one at the bottom, so as to create the geomodel between the horizons. Although various methods are possible, we recommend to interpret one line at a time. Once a horizon has been interpreted, click on the Mark button or press M to validate the interpretation. The edited horizon will appear on the seismic with a specific color. The preview of the 2D geomodel can be activated from the Properties panel Display tab by ticking the Activate and Model options. Alternatively, press T to activate or deactivate the model preview. During the interpretation of a horizon, it may happen that two parts of the same horizon are overlapping. Each time this conflict occurs, click Apply to validate the modification or Cancel to cancel the modifications. For each 2D line, the more interpreted horizons, the more refined the preview model. When satisfied with the 2D line interpretation, move to the Intersection subviewer and start connecting corresponding horizons on both sides of the intersection. The user must select the Cross Navigation tool to connect horizons on both sides of the intersection, and press W to validate these horizons as similar on both sides. When the link has been made between the two corresponding horizons, press M or click on the Mark button to mark the horizons. PaleoScan will consider as the same isotime constraint the horizons on both sides of the intersection. The connection of horizons on both sides of the intersection also allows to apply a mistype correction at the intersection. This mistype correction can be activated from the Properties panel Display tab by clicking the Shifted option, or by clicking on the Shift button at the bottom right of the viewer. A yellow triangle will appear on the corner of each sub-viewer indicating that the Shift option is activated. Then start interpreting the second line of the intersection so as to complete the preview model. Following the same method, the other lines can be interpreted by moving the cross-navigation cursor on the horizon viewer. Move the cross-navigation cursor on the horizon viewer to display any desired intersection. It is important to save the model grid interpretation once in a while with the Save Interpretation button from the Model Grid module toolbar. We recommend to assign a relevant name to the interpretation, for instance, the date of the day. When each line of a set is sufficiently interpreted and the connections at the intersections are numerous enough to provide a well-constrained preview model, the creation of a 2D geomodel can be undertaken. To do so, from the Model Grid module toolbar, click on the Geomodel Creation button and select the Compute Geomodel option. On the displayed interface, take all lines to create a 2D geomodel on the whole set, or single line and choose the line to create the geomodel on one 2D seismic line only. Exclusion zones can be specified to remove soil tectonic or basement from the geomodel, for instance. Tick the Model with Corrected mistake option to create a 2D geomodel including the mistake corrections. Similarly, tick the Seismic with Corrected mistake option to recreate a new seismic 2D line set accounting for the mistakes correction. 2D line set including the Z variance shift and the Z original position can also be created. Click on Save to create the new 2D geomodel. Give a name to the model and click OK to launch the computation. The new created 2D line set corrected from the mistake is stored under the 2D line set folder of the 2D line tab of the project browser. The basic and the corrected from mistakes geomodels are stored under the 2D line set model folder of the 2D line tab of the project browser. Double-click on the 2D line set model name to open it into a 2D viewer. As for any viewers, the sub-viewers can be synchronized both in terms of zoom and color bar. Right-click on a 2D line set model name and click on Open in 3D from the context menu to open the 3D line set model in 3D. The color scale of a 2D geomodel can be changed, for instance, to display continuous color. A 2D horizon stack can now be built from the 2D geomodel. To do so, go into the Horizon Stack module and click on the New Horizon Stack button and select New 2D Horizon Stack option. In the displayed interface, select the reference geomodel and select the reference 2D line set for the background. The upper and lower boundaries of a horizon stack can be modified by moving the gauge button at the right of the interface. The boundary position can be more precisely adjusted with a top and bottom blue and green arrows. The density of a horizon stack can be modified by increasing or decreasing the number of horizons. The horizon stack preview can be activated by ticking the horizon preview option. Click on Run to create the 2D horizon stack. Assign a relevant name to the horizon stack and click OK to start the computation. A 2D horizon stack can be opened in a 2D horizon stack viewer by double-clicking on the 2D horizon stack name. Scroll through the stack to observe its geometry. The survey of the stack can be modified by double-clicking on its boundary. Once selected, it can be rotated, squeezed, and stretched. From the Horizon Stack module toolbar, click on the 2D Horizon Stack Interpolation button to start the interpolation. Several interpolation methods are available: diffusion, inverse distance, and kriging, with potentially several sub-options. Choose the interpolation input and the area type. Select from the polyline constraint or the survey the limits of the interpolation. Note that the current viewer survey can be saved. Click on Save to create the interpolated horizon stack. Assign a relevant name to the name of the stack. For instance, mention the interpolation method. A 3D horizon stack can be opened in a horizon viewer by double-clicking on its name. Alternatively, right-click on the 3D horizon stack name and select the Open in 3D option from the context menu to open the 3D horizon stack in a 3D viewer. In the 3D viewer, double-click on the horizon stack and scroll up and down to visualize the horizon stack through the seismic interval. To create a 3D geomodel based on the horizon stack, From the Horizon Stack module toolbar, click on the 3D GeoModel from Horizon Stack button. In the displayed interface, select by clicking on the magnifying glass the possible input for the volume or extraction area. Drag and drop the desired volume or extraction area into the field. Then, select drag and drop the desired horizon stack constraining the GeoModel. If wished, tick the Create X-line and/or Create Time Slice to create the X-line and time slice dimensions of the GeoModel directly from the stage. Click on the Preview button to visualize the preview of the future 3D GeoModel. Eventually, click on Save to save the 3D GeoModel. Make sure to give a relevant name to the GeoModel and click OK to launch the computation. Several displays of the GeoModel are possible. For instance, right-click on the name of the GeoModel and, from the context menu, click on the New Sculpted 3D Cube option. In the displayed interface, select a bounding method and, on the corresponding field, select the horizon stack or horizon that will geometrically limit the top and bottom of the sculpted GeoModel. Create the missing X-line or time slice if necessary. In the 3D viewer, double-click on the top surface of the GeoModel to scroll up and down the limit. The same can be done with the lower limit of the GeoModel. Similarly, select the faces of the GeoModel and scroll back and forth to adapt the limit of the GeoModel. Z value can be displayed on the top and bottom of the horizons, limiting the GeoModel. To do so, double-click on the top horizon, for instance, and from the Properties panel, Display tab, select Z value instead of Data. The same applies for the lower bounding horizon. In conclusion, the 2D line set interpretation tools of PaleoScan 2018 allows manipulating 2D seismic data and obtaining a model grid-based 2D relative time model. The extracted 2D horizon stack can be interpolated and provide constraints to create a basic 3D GeoModel underlying the main structures of a sedimentary basin.